All right, you ready? This is kind of like this little box in definition kind of rears its head all the time. Is it integral to like understanding math? A little bit. I mean, if we use these words and you didn't know what they were, that would be a problem. Are they going to inhibit you from doing math? No. But you should know what they are. So anyway, definition-wise, we'll just go over. Like a natural number is a number in the sequence 1, 2, 3, 4, 5, and so on. And then a whole number just includes 0. Okay? And then an integer number is just a number in the sequence. It could be anything. Well, I suppose the natural and whole numbers look like they're just at positive values too. Whereas an integer number could be negative. Okay? And then a rational number is a number that can be expressed as a ratio of two integers where the divisor is not 0. Okay, do we know what the divisor is? Just the thing on the bottom. And it's, I know that's the case because what happens if you try to divide by 0? Has anybody ever tried that before?
Siri roasts you on your cookies thing.
Yeah, Siri doesn't like it. What happens? You break your calculator if you try and divide by 0. It doesn't like it. Okay? So you can't divide by 0. That's kind of an important concept for later. But so you'll see like rational numbers can be expressed. So 0.75, is there another way to represent 0.75? Yeah, so like if you're able to write something like a particular decimal as something divided by something else, that's a rational number. Okay, so for 0. That's a good example. 0.75, I could take 3 and divide it by 4. That gives me 0.75. Okay, that's important. Okay, if you can take something and write it, like if you can take a numerator and divide it by a denominator and get whatever number it is in question, then it's a rational number. If you can't do that, then it's irrational. Okay, so a number that cannot be written as the ratio of two integers. Okay, so for instance, Miss Beer said, this is a good little activity here. This is like a 1 by 1 by 1 by 1 kind of box. And if you wanted to measure something across the diagonal, how would you find that? We did this like not last week, it'd be Monday. It's been like forever, yeah.
A squared.
Yeah. So you could do a squared plus b squared is equal to c squared, right? And so to solve for c there, you would do 1 squared plus 1 squared is equal to c squared. So you'd get 2. Have we done like getting rid of squareds yet? What's the opposite of squaring something? Yes?
Square root.
The square root. So if you square something, you can square root it. That's the opposite. So that's be like how you would solve for c here. I can't remember because I'm helping Miss Anderson's class or helping out Miss Anderson's class in the morning. Like I'm kind of getting a little bit of bleeding between like what we talk about in here and what I talk about in there. So we're going to get the square root of both sides. So we get the square root of 2. Does anybody know what happens if you try to square root 2? Does anybody know what the answer is? No, not pivotal. Yes, London. Anybody? Anybody?
I might know it, but I want you to get the answer for it.
I don't know. I don't know what it is.
Okay.
I'd have to type it in the calculator.
There's okay. I was going to refer to the imaginary numbers.
Not quite.
And
Not
you
quite.
can use, yeah.
Yeah.
Square
The imaginary would be the square root of a negative number. That doesn't exist.
Right, yeah.
But the square root of 2, anyway, that's not the point, whatever the number is. The point is it's something, it's this really long decimal, whatever it is, that can't be like, it doesn't repeat, right? And it can't be represented as a fraction, like a number divided by a number. Just as this weird bunch of just random numbers. Perfect example is, who can recite pieces of pie? Yes? Go for it. Let's see who can win. Who knows the most digits of pi? I think, if I recall correctly, because I've heard Kenneth talk about this before, I think he can get up quite high. So let's see.
No, I can't get that.
All right, what do you got?
3.14159653.
Okay, that's even more than I could do.
That's pretty much.
Okay, so what's the thing with that? Why is pi listed under this irrational number?
It's infinite.
It never ends. How are you going to write a fraction to represent pi? All those decimals, 3.14159. How are you going to represent that as a fraction? You're not. Okay, so that's the key distinction between a rational and irrational number. Okay, something easy like 0.75, or even something that repeats itself. Okay, but something that's completely like almost seems random, like pi. Although we know pi is not necessarily random because we figured it out somehow. But it's not. How are you going to represent that as a fraction? You can't. Okay, so it's irrational. Okay, and then the real numbers is a number that is any of the sets of the numbers above. Okay. So here's an example of a fraction. Hopefully you've seen one of these before. And fractions are going to become your friends because fractions don't have rounding error. Decimals do. Okay. So for a mixed form, for example, something like, I don't know, 4 1/4, 1/3, say. Okay. Do we know how to switch something from a mixed form into a improper form? Not bad, actually. It's one of these things, one of these skills that like you can get quite far in math without ever actually, well, I shouldn't say that. It's kind of important. It rears its head from time to time. Do we know how to switch this out of mixed into improper? Do we know what an improper fraction is? What's an improper, let me start there. What's an improper fraction? Give me an example. Just yell one. It doesn't matter what it is, yeah?
7/3.
Okay, 7/3. It's where the numerator is greater than the denominator, right? So that's just an example. How would we switch something from mixed form into an improper form? Do we know how to do that? Yes. Oh, maybe Kenneth. Let's hear what Colson says, and then.
You multiply the denominator by the whole number and then add that to the numerator.
Yeah. So I would say, well, and I heard divide from Kenneth, so I'm interested in what that's about. So we'll see what that is. Okay. So what we're gonna do is take the bottom, multiply by the side, and then add the top. Okay. So this 4 1/3 as an improper fraction would turn into 13/3. You see how that kind of happened? 3 times 4 is 12, and then add the top. This is 13. Okay, no, what were you going to say, Ken?
Oh, I thought you meant for improper form.
Oh, I see. Okay. So with this one, let's circle all the rational numbers. So just using the definition above, right? So rational numbers, a number that can be expressed as a ratio of two integers where the divisor is not 0. Okay. Can we write, what's 5 divided by 3? If you just did 5 divided by 3, obviously it can be written as a decimal. Is the decimal a nice one? Is the question. Do we know? What is 5 divided by 3? Does nobody own a calculator? Okay, I know we've done and tried to emphasize quite a bit over the last 2 days about using calculators, but they're definitely not the enemy. You can use them when I say, give me a number. What is it, Allie?
1.666.
All right, so, okay, so it's 1.66 and with a 7 or whatever repeated, right? So that's kind of like, we have this repetition in the decimal, and obviously that has been built somehow, right? It's been 5 divided by 3. So that would be rational, right? What about the square root of 3? What's the square root of 3? I don't expect you to know the square root of 3. That's not a memorizable thing, right? So you just type it in and see what happens.
It's 1.732.
Does it repeat?
No, there's just a bunch of.
So it's just a bunch of random numbers afterwards, right? How are you going to represent that as a fraction? You're not going to be able to, right? So that one I would say is not rational. Okay, it would be irrational. Okay. What about the square root of 4? Do we all know the square root of 4? Please don't pull out your calculators for that one. What's the square root of 4? 2. Okay. So that's obviously rational. Okay. And what about 0 divided by 3? Is it a trick question? If you have nothing and you try to break nothing up into 3 smaller pieces, what do you have left? Nothing. It's still nothing. Not magic. So, right. So I get a nice number from the division, so that has to be rational as well. And then -6. -6 have any like absurd decimals after it? No. It's good as well. Okay. Does everybody kind of get the idea? All right. So we're going to write each rational in its lowest terms. Does anybody ever like reduced fractions? That's all this is saying. Okay, a rational is a fraction, and lowest terms is reducing. Okay. So 6 divided by 8. Well, the two negatives are going to knock themselves out. Do we agree? So we're not worried about the negatives because a negative divided by a negative is going to turn into a positive. So I know my answer is going to be positive something. But when it says lowest terms, you want to go as low as you possibly can go, right? And so you're going to look at the two value, or like the numerator and the denominator, and you're going to see like, what could you divide? What's the biggest thing you could divide both of them by, right? So what's that, Allie? 2. I think 2 is probably the biggest you can go, right? So I can divide the numerator by 2, and I can divide the denominator by 2. And when I do that, I'm going to get, do you want to write? No, we don't need the negatives because they're going to cancel each other. So you're going to get 3 over 4. You can confirm that's the case. If you typed in, if you're ever in question as to whether or not you're right with a reducing, type them into the calculator. We know 3/4 is 0.75. And 6 divided by 8 should, in theory, if it's the same fraction, just smaller, should, in theory, still be 0.75. You can always check if you're right in your reduction. Okay. Okay, 12 divided by 9. -9, sorry. What's the biggest number that goes into both of those? 3. So let's just divide both of them by 3. So we're going to get 12 by 3 is going to be 4, and divide -3 by, or -9 by 3 is going to be -3. So you get -4/3. Anybody disagree? Again, same thing. You could check both of those. See if you got the same decimal number if you were ever in question. Okay? Anybody have any questions with that first page? Okay. Going to go into a very, this is an important skill. Okay. All right, we've already talked about it a little bit. Okay, we're just going to go through some more examples today. So rules for multiplying fractions, okay? Right off the bat, I'll bring your attention to, so change all fractions to improper form. You can imagine the reason why that's there is how would you possibly do a question like this? That's a tough one if you didn't switch it from mixed to improper, which is why step 1 is to do that. Reduce numerators and with denominators if possible. That just like that just makes the numbers that you're working with a little bit nicer in terms of like overall size. Simplify positive and negatives. Multiply numerators and multiply denominators. Lowest common denominator not needed for this. Why is this not needed? Are we adding and subtracting? Not yet. So we don't need lowest common denominators, right? We're just multiplying. So yesterday I showed you we're just going to multiply the top and multiply the bottom. That's different than adding and subtracting. Please do not do that when we add and subtract. That's a no-no. Okay? That's why they're two separate lessons. Okay? So, and then always reduce your answer if possible, and then always leave your answer in reduced improper form unless otherwise stated. Okay, and assign the negative to the numerator or in front of the fraction, not in the denominator. Okay? And then we'll come back and dealing with the rules of for dividing fractions when we get there, okay? Unless we get to it right now, I'm not sure. We'll come back to it when we get to F, okay? So let's just have a go with this, okay? First step, get some practice. I totally did not mean to already do this, but I already did it. Did not mean for that. I just made one up. So how do I switch a mixed fraction into an improper fraction? Okay, kind of an important skill. We take the bottom, multiply by the side, and add the top. Okay, so 3 times 4 is going to be 12, and plus 1 is going to turn into 13. You get 13 by 3 multiplied by 9 over 5. Are we okay with that? Okay. Now the next step is you just take the top, multiply the tops together, and multiply the bottoms together, and that's it. Or you could reduce if you needed to, but I don't know if there's anything you can reduce in there. Right? Like I don't think there's no common multiple between 13 and 3, and there's no common multiple between 9 and 5. So you're just going to go right at this, right? So you're just going to go, okay, I'm going to multiply the tops together. Multiply the bottoms together. I'm going to get a new fraction, and maybe I can reduce that fraction. Maybe I can't. Okay, and we're just going to leave it or reduce it. Okay, so 13 times 9, do we know what that is? 13 times 10 would be 130. Take away 9. That'd be the fast way if you're not doing it with your calculator, right? 130 times 10, 130 take away 9 would be 13 times 9. So it would be 121. Does everybody agree? Yes, Aaron?
It's faster if you just cancel out the 3 and the 9.
Okay. Yes. Okay. I will do that in a sec, Aaron. Yes, that's worth doing. Okay. Let's do it this way because I think this works. And then I'll show you what Aaron just said as well. Okay. So we get what did I say? 121 divided by 15. Does that reduce? I actually don't know. Is 15 going to 120? I don't think so. No. Let's skip over it. That's it. I don't think that's... Somebody can try and reduce that for me. I don't know if that goes any smaller, though. Okay. Now, I'm just going to do something that Aaron just said. And we have already talked about it a little bit today, I think, somewhere else. Which is why I brought it to your attention. I just wasn't sure if it was going to come up this quickly, but it did, which is fine. Okay. Do you have to worry? Is there any plus signs or minus signs there? So you're actually at ease because you're not worried about any funny business going on with the plus and minus sign. So something nice you can do something. Yes, Aaron? Yes?
So for the first one, it's 13 times 9 would be 117, which would make both 117 and 15 divisible by 3, which means you can reduce it.
Did I get this wrong?
Yeah.
Yeah, you subtract 9 instead of subtracting 13 from.
Oh, I did subtract. Thank you, Aaron. That's right. Silly me. Trying to be quick. There we go. There you go. Okay. My bad. Now that is reducible, Aaron? So what's it go to?
It would go to
What's it divisible? What are both divisible by, Aaron?
30.
Okay. Okay, so you can divide both by 3. We're going to get, obviously, everybody can do that in the denominator. That's be 5. Okay. And what's the numerator? How many times does 3 go into 117? That's a little trickier. 30. Okay. Okay. Now I'm gonna bring your attention to something Aaron said, because this is the way I would see how everybody, like, not everybody. When you start dealing with these bigger numbers like the 13 times 9, right? There's something you could do to avoid that situation, right? And this gets at what I was asking. I don't see any plus signs or minus signs, so I'm not too stressed about this, right? But very, very easily, there's nothing wrong with rewriting this fraction in this way. And you tell me if you're happy with this or not. And this is probably the way I would have done it. I'm fixed on like this multiplication of the brackets, but if I had seen this in like an actual math problem that I was working on, I would have seen this. So there's nothing wrong with switching things around. Because what did we discuss yesterday? Does it matter what order you multiply these things in? No. So why can't you just switch this around and go 9 times 13? Well, sorry, one sec. I don't want to like throw a wrench at. I'm just trying to like, what's the best way to do this? Anybody not happy with what I just did there? If we're not worried about the order in which we multiply the denominators of the numerators, I know I've changed the fractions, but the math will work out the same. I've done this for a reason. You might not choose to do it this way, but I've done this to illustrate a point to you. What is 9 divided by 3? 3. Right? So then you would get 13 over 5 times 3 over 1. And that makes the numbers a lot smaller. Okay? Now, would I rewrite the fractions like this? No, probably not. What I would say from here, I recognize that 9 divided by 3 is going to be 3. Everybody see that? So that makes the numbers that you're multiplying together, then you don't run into this silly situation where we had 4 extra digits, or we just did the multiplication wrong in our head, right? You don't run into that situation because the number's not as big, right? So then you'd get 13. Basically what would happen is you'd say, okay, 3 cancels with the 9 and it gets replaced with a 3. So you get this. What's 13 times 3? Top times top, bottom times bottom. They're much smaller numbers, right? That's why we did that. 13 times 3 is 39 by 5. I'm a little uneasy about switching the fractions around, but I just did that to like illustrate a point to you, okay? If you're multiplying two fractions together, you're multiplying numerators by the numerator, and you're dividing by denominator times denominator. So in reality, it doesn't matter what your order you're doing things in, right? Numerator to denominator. You can cancel some stuff out like that. Okay? Does anybody have any questions to that? You see the numbers on the right are much smaller than the numbers on the left, which is convenient. Okay, you don't have any reduction to do that way either. So we basically canceled that factor of 3 out. Okay? Any questions? That gets to Mr. Polling's part about point about a lot of this you could make it easier from the standpoint of like you're not needing a calculator. Okay, there's just minor manipulations you can do to what you see to make it more manageable. Okay? Without a calculator. You gotta look for the little tricks like that. Okay? So why don't we apply that approach to the next question here? Because right off the bat, it looks like, does 8 go into 24? How many times does 8 go into 24? Yes? 3. So basically what we're going to do is we're going to take the 8 divided by the 24, and we're going to replace the 24 with the 3, right? So we get negative 3 over 8, oh no, not 8, 1 times 3 over negative 5. Numbers got smaller there. Nicer to work with. Negative 3 times 3, and then 1 times negative 5. What are we going to get? Negative 9 by negative 5. Two negatives, what? Cancel each other out. Do we have any questions? Okay. We'll do C. Okay, same thing here. This would be the recurring theme. I would try and just like find is this addition subtraction? I know there's some negatives in there. Is this addition subtraction? It's still multiplication, right? And we know it's multiplication because of the presence of these brackets. So don't worry about the negatives. It's just saying that fraction is negative, right? So it's the same thing. A 4 can cancel with the 4. You're gonna be, and then you replace. What's 4 divided by 4? It's just 1. Okay, so 4 divided by 4 is 1. So you can replace both of them with a 1, and then the question would look something like this. Do you see anything else you could do? I mean, you could at this point just multiply it out, right? And then you should see it. We'll leave the negative out front. And then we're gonna go a negative multiplied by a negative turns into a positive, right? So on the inside of the brackets, I'm gonna get a positive, and I'm gonna get positive 39 by 13. Would everybody agree? If I multiply top and top and bottom, and we've already seen a few times today, 39 divided by 13 should be 3. Okay, and then I would just, you don't need the brackets anymore. Okay, that would be your final answer. And don't forget, like, if you wanted to, you could type that into your calculator, and you should, like, the calculator would just skip all of this and just jump and give you the answer if we were to multiply those together. But again, as Mr. Polling's saying, like, if you don't have access to a calculator, you're going to have to be able to manipulate what you see on your page somehow, however that might look. Okay? So I just prefer not to have to multiply 15 by 18 because I can't do that in my head, right? What's a little easier though, if I recognize the fact that like 15 and 30 are kind of related and 9 and 18 are kind of related. Can everybody see that? It kind of makes your life a little easier, right? So let's deal with the 9 and 18 first. We'll go negative 15. 9 cancels with the 18, but then what's 18 divided by 9? Be 2, right? If this, well, I'm not even going to say that because the next one's going to be like that. Okay, so there. So you're going to have 2 over 1, right? Which means the 2 is in the numerator, which is going to replace the 18. Did we see why that's the case? Okay, you'll see like the comparison in a second, right? So you're going to get negative 15 by 1, and we're going to have to multiply that by negative 2 over 30. I haven't dealt with the other piece yet, the green pieces. Do we agree? And again, if you could do 15 times 18 in your head and then 9 times 30 in your head, and then do the reduction on that, by all means go for it. But I think what we're trying to show you here is that like You could do some simplification before you have to get to the stage of reduction, or the simplification takes care of the reduction for you in most instances. Okay, it finds what those common factors are, right? Okay, so this time though, hopefully this does like a better job here. With the green pieces, you get 15 divided by 30. What's that? As a fraction. Could I reduce this fraction? So maybe don't think of this as 15 divided by 30 and try and come up with a decimal. Maybe don't think of it like that. Let's treat it like a fraction. How would you reduce that? Yeah? Say that again?
1/2.
It's 1/2, yeah, but how would you get to the 1/2? Both of them would be divisible by 15. Would everybody agree? Okay. And so watch what happens where the 2 ends up in this particular question. Or this part of the question anyway, I should say. So 15 divided by 15 is 1/2. Because if you end up with 1/2, I want you to relate that to the 2/1, how we got the 2/1. So the 2 is now in the denominator. So the 15 cancels with the 30, and then we get a 2 down in the bottom. This should be -2. Anybody disagree with what's there? So your final answer should be something like the negatives will cancel out, because 2 negatives turn into a positive, and 1 divided by 1 is 1 times 2 divided by 2 is also 1. So we should get +1. Does anybody disagree with what's going on? This is a new thing for me, teaching this. So that's okay if that didn't go well, it's okay. Ask a question, because I'm not necessarily 100% happy with how that got delivered. It's the first time I've done that before. That's something that I just have taken for granted. Somehow has just found its way into my head over the course of like 6, 7, 8 years of math, and never had to put any thought into like actually explaining why that's the case. Okay, so I'm like not necessarily happy with that explanation, but if it doesn't make sense and you need to see something again, I'm happy to do it. Okay. Are we okay to move on to the next question? We could do another one tomorrow if it comes up in the homework, okay? I'm sure that'll come up in some of those practice questions. So why don't we jump down to E here and apply what we said earlier in the other lesson. What does the squared physically mean? I'm going to show you two approaches to this as well, just to illustrate that it is actually the case. What's the squared actually mean? I think we used, what was the definition you said? Repeated multiplication. Okay, so we've got, is the negative a part of that repeated multiplication is the question. That negative is not inside the bracket, right? So it's not a part of that repeated multiplication. It's just going to float down, right? But your next line could look like one of two ways, and I will show you both in a second, or the other one in a sec. Repeated multiplication tells us that it's going to be 5/6 times 5/6, because there's two of them. That's what the squared is telling us, right? And then you would multiply that out. It'd be negative 25 by 36. Is that reducible? Is it?
Yeah.
What are you going to divide by?
5.
Does 5 go into 36?
Sorry, no.
That's all right. I'm thinking too. You can't divide them both by 2. Can't divide 3 doesn't go into 25. 4 doesn't go into 25. 5 will, but 5 won't go into 36. 6 skips over 25. 7? 7 going to 25? I don't think so. 8? No. 9? No. 10? I don't think it's reducible. Does anybody disagree with me? The other thing, the nice thing about some calculators too, if you type this in your calculator and you hit equals, sometimes some calculators, not all calculators, some calculators won't even give you a decimal. They'll give you the actual reduced fraction. Okay, so calculators are helpful in some, well, they're always helpful, but are more helpful than I think people give them credit for sometimes. They're not just about like adding and subtracting and multiplying numbers together. They will actually do some reduction for you. Okay. Okay. Now, as promised though, if you ever see something like the squared, another way, maybe a faster way, I don't necessarily know if it's faster or not. The negative is still there. The squared is on the bracket. The squared, doesn't matter what the exponent is. The exponent has to be distributed into both parts of the, or let's just as a general rule, exponent goes into everything inside the bracket. Okay, so what's that actually look like? Well, it turns into 5 squared over 6 squared. Okay, and we're going to see more of this. We're going to see harder questions in our like exponential unit, or like power laws, exponent laws. We get there, okay? So we're going to get negative 5 squared is 25, and 6 squared is 36. Okay, and hopefully as you go through this course, like, and we show you as many representations of the same problem as we can, they should all give you the same answer if your answer is A, correct, or if B, the second method is actually true or valid. Right? And you should always be, like, have that in the back of your head. Can I do this a different way and get the same answer? If you can, chances are you're right. If you can't, either your method's not valid or your first answer is wrong. Okay, this is almost like a way to check. Being able to do things in multiple ways is a benefit. Okay? Now, we've got a few division questions. And then one at the end here. Okay? So let's just back up as promised. We'll go back up and look at the rules for dividing fractions. And we saw a couple yesterday. Change all fractions again to the improper form. Okay, so if you have a mixed fraction with like a big coefficient out front, switch it to the improper version, okay, and then change the division to multiplication, and change the fraction after division sign to the reciprocal. Okay, and we learned what reciprocal was yesterday. Okay, it was a flip. We're just going to flip the fraction and then multiply it by. It's basically this is a very fancy way of talking about that, but we're going to, like, instead of division, we're going to multiply by the reciprocal, or the flipped version of the fraction. Okay? Which is particularly useful when you have fractions inside of fractions, which you'll see later at some point in your career. Okay? So why don't we first start with the first bullet point and switch this again, this mixed fraction, into an improper fraction. 12 times negative 2 would be negative 24 plus the 1, right? Over 12. Okay, I'm just writing the work down. Maybe I'll move this. Right? Negative 24 plus 1 should be negative 23 by 12. And that is, we're saying, is divided by 1/6. That's literally what's on your page right now. Okay? Just without the math symbol. So then you might be thinking, how do I deal with that? Because that'll come up. Maybe not in this course. Might see it next year. It'll come up somewhere. So how do you deal with that? Well, we'll just go back to our rule there. Instead of division, we're going to write these two fractions. Well, the first one anyway. Negative 23 by 12. Right? And what did it say? It said multiply by the reciprocal. So we're going to grab this fraction in the bottom. What's the reciprocal of 1/6? Aaron, question? Problem?
Wouldn't the negative carry over to the 1 over 12 as well?
Negative 1 over 12. That's why this is all negative, though.
No, but then you added 1 to negative 24. Wouldn't it be negative?
So I just did...
24 minus 1?
I don't think so. I did this times this. I'm just following the same rules. So negative 12 times negative 2 made the 24, and then I added that positive 1 in the numerator. I think.
But
Is that right?
wouldn't
Did I do it
minus
wrong?
be-
Yeah, I think it'd be 24.
Wouldn't that minus at the front of the negative 2 also make the 1 minus 2?
Yeah.
Oh, I see. The whole piece is negative.
Yeah, mixed numbers don't. That's why I don't really use them. They follow weird rules.
Yeah. Well, this just in itself is like, I don't think this happens too often. Like, I think you're right, Aaron. But you can see, like, even my inexperience with this, right? Like, I don't know why they exist, because you can't really do much with them. Aside from what it would tell you is like, if this was like 2 and 1/12, that's a little easier because it's positive. But 2 and 1/12, that tells you that there have already been 2 like whole, like if you treat these like pies, you've got like 2 whole pies plus another 1/12 of it. That would be like the use of a mixed fraction. But to do any math with it, it's kind of like weird, right? You don't really use it. So you're right, Aaron. And I'm thinking now, we're gonna have to backtrack here a little bit. It's weird because I always thought the reason why I'm like and I didn't put any thought into it at all, because I've always, like, when I figured this out, I never took into consideration this negative piece, right? Like what it actually represents. I always just follow the rule of 12 times the side plus the top, which I guess breaks down in this particular situation, right? Because the whole fraction's negative. So Aaron is correct, it appears. And that's what you're saying, Aaron? It's the one's negative as well? Okay, because the whole thing is negative. So which would change your, like, that's just not a big deal. It just changes to negative 25 instead of negative 23, but. Okay. Now, are we okay now? Are we all right? Okay. Keep correcting me if I'm wrong. Somebody's catch it. Okay. Okay, what was I saying? Oh, take the original fraction, whatever it was, the improper fraction, right? You get negative 25 by 12, and we're going to multiply by the reciprocal of this fraction. What's the reciprocal of 1/6? Remember, the word reciprocal means flip. Right, so you're going to just take, it's going to be 1/6, but it's going to be flipped. Does anybody have any issues with that? So now you could do this. Oh, you could do this and this, or you could recognize this part again, like we've done a number of times today. The 6 and the 12. What's 6 divided by 12? If you divided both of them by 6 and reduced this fraction, you'd get 1/2, right? So we would say, okay, well, we're going to get negative 25. That 12 gets replaced with a 2/2. Does anybody not like that? Because you can also, like, you don't have to do it that way, right? If that's like, again, that's one of those things that I'm taking for granted because I've done it so many times, right? If you don't like that, you can go top times top. What's negative 25 times 6? That'd be negative 150, right? And then you could divide that by 12. The issue with doing it that way is you have to find, like, what's the factor that goes into both of those? Is 12 going to 150? 6 going to 150? 4 going to 150? That's the problem with doing it that way. Okay? Should we hit pause there? We'll let you guys do I suppose you could do, we could try whatever you wanted, and if there's something you're stuck on, we could take it up tomorrow. But try as much of the practice as you can get, okay? And definitely try that table from the other lesson, okay? And we'll deal with that stuff tomorrow.